let's start by talking a little bit about energy and how energy relates to matter. So we're not going to get into great detail, but I do want to talk a little bit about it because it sort of shapes how we look at things. We got to get some vocabulary on the table. So first of all, when we talk about chemistry itself, chemistry is defined as the study of matter and its transformations. So transformations of matter happen because of energy. So either it takes energy to have a transformation happen or the transformation gives off energy. Either way, energy is a big piece of the story in chemical transformations. And so we kind of need to know a little bit about it up front. We'll go into more detail later on in the semester. So, and again, we talk about matter undergoing transformations. So let's just kind of get a couple of things on the table that you probably know, but make sure that we're all clear on the same definitions. So matter is defined as anything occupying space and having mass. Well, volume is the amount of space something takes up. So another way is often it's said anything that has mass and volume. Those are really two equivalent definitions. So we're going to start off with a few basic things that I hope we're going to agree on. So one, all matter is composed of atoms. And the atoms are much too small to be seen. Even with our very best microscopes, we have to use some indirect methods to see atoms. And there's more than one type of atom. We have oxygen atoms, we have carbon atoms. So also atoms can't be created nor destroyed. So they've been in existence for eons, and the same atoms that were there eons ago are still here around. So we can do things, we can not convert it to another element except through nuclear reactions. So there's a little bit, but we're not going to talk about them in this course. Atoms can't be created or destroyed as far as we're concerned. Also, atoms can stick together. We call that bonding. So we have a couple of things that they can do that we're going to talk about this semester. So let's get back to the energy. Okay, so energy is defined, it's really more in the physics realm, but again, there is no science that's separate and unto itself. They all interact. So energy is defined as the ability to do work. It's has the ability to supply heat, for one type of way that it can happen, or it has the ability to move an object. Like those would be another kind of work. So it's a kind of amorphous thing to sort of say what energy is, although we kind of have an intuitive sense of it. We're going to break up energy into talking about potential and kinetic energy. I'm guessing you've heard this before. We talk about potential as being stored energy, and kinetic energy as being the energy of motion. That is true, but again, we're talking about matter. We're not talking about baseballs, and we're not talking about cars. We're talking about matter. So we're talking about substances, and we're really thinking about those atoms. And so in chemistry, we're talking about what kind of potential energy do atoms have, or what kind of kinetic energy do atoms have. And so in chemistry, when we're talking about potential energy, we're talking about energy related to the location of the particles relative to one another. So are they here and here? Are they here and here? What's going on with the particles? That is also true with the other kinds of potential energy you've had. We've probably just not defined it that way. When we talk about, things that are like, if a ball is at the top of the hill, it has more potential energy. That's because it is farther from the center of the earth. And so the distance between the two objects that are being involved in that case is higher up, so it's farther distance. So it still is the gravitational energy, potential energy, still is based on location of the items. It's just a little less clear in those cases, and we usually approach them from a different viewpoint. So we're thinking about where are the particles, where are the atoms. That's going to tell us about what potential energy they have. And then we have a kinetic energy, which is the energy of motion. And again, when we talk about atoms, we're talking about, well, how fast are the atoms moving? And that is really going to be associated with something called temperature. I know you know what temperature is. So temperature is a way that we can access how quickly are those atoms moving. So we're really not going to be talking about how quickly the beaker moves, but rather the atoms inside the stuff that's in the beaker. So let's get into a little bit more about the potential energy of particles. So again, we the particles' atoms are actually attracted to one another. So we think of them as being like two independent things that are hard and they just hit and bounce back. But in reality, they're a little bit attracted to one another. Protons and electrons are a little bit attracted to one another. And so when you have two particles that are attracted, the potential energy when they are far apart is greater than the potential energy when they're close together. If they're far apart, they have the potential, because they're attracted, to move closer. And so far apart is more potential energy than close together. If they were repulsive, if I had like two like charges, like two negatives, it actually flips, but we're not going to be talking about this. One way to kind of remember this is to think about a rubber band. You know, it has more potential energy to hurt you when you have it stretched far apart. So we can think about the two ends of the rubber band as being far apart would be more potential energy than when they're close together. So if we think about the energy within matter, we can sort of wrap up a little bit and say that potential energy, again, is stored energy due to its position. That is always true. So a ball at the top of the hill it has a potential to fall down, and a stretched rubber band has a potential to relax, unstretch. And in matter, we're talking about how far apart the particles are. So the three things that are going to relate to potential energy are going to be state. Gases, the particles are very far apart compared to solid, where they're very close together. So gas has a lot of potential energy, more potential energy than a liquid of the same substance than a solid of the same substance. Also bonding, right? If they're stuck together, they're close together, bonded atoms have less potential energy than unbonded atoms. And electrons, inside the atoms are electrons, and how close they are to the nucleus. If they're far from the nucleus, they have more potential energy than if the electrons are close to the nucleus. And again, we're going to get into these specifics later on in the course, but I just kind of want to lay that foundation. And we said the kinetic energy, which is the energy due to motion. So if we were talking about, baseballs, it's how quickly the baseball is moving. But in chemistry, we're going to think about temperature. The temperature of a sample can be, we're really measuring that movement of the vibrational and translational energies and rotational energies of those atoms as they're moving inside. Okay, so probably you also remember the law of conservation of energy, and that is that energy cannot be created nor destroyed. So we can transfer it from one type to another, right? And in our case, we can take a collection of matter and transfer energy from the collection of matter to the surroundings, which is more matter, or from the surroundings, which is a collection of matter, to the system, which is another collection of matter. So we will talk about that, but basically all of these transformations of a sample of matter are going to involve energy. Just quickly, let's talk about the units of energy. We're going to really see in this course two types of units, joules and calories, and they are related. We can, if we know how many joules, we can convert it to calories. It's about 10 joules. If you were to take a 1 kilogram mass, so about 2 pounds, and lift it very quickly up to 1 meter above the floor, about a little bit close to a yard, that's going to be about 10 joules. So that's not too much, but of course it does add up. 1 calorie is equal to 4.184 joules. However, when we're talking about these kinds of calories, be careful. They're not the same as a nutritional calorie. Nutritional calorie is actually much more. So 1 food calorie, and nutritionists will sometimes use a capital C, is really a kilocalorie. So it's really 1,000 of the calories we're going to use in this course. So when you're dealing with nutritional studies, you just have to be careful to make sure that you know which units we're talking about. So just to wrap up, let's try some practice. Which one has more potential energy, liquid acetic acid or solid acetic acid?